We find a lot of high alloyed and stainless materials in the oil and gas, aircraft and medical industry where we didn't have the perfect tool for it. The target was to improve the performance in these difficult to cut materials, even under HPC conditions where we have a small radial and a high axial depth of cut, where we need the high feed rates to create the biggest cutting volume per time. We saw the need for a sharper end mill to cover all these applications. So with the RF100 speed, we developed a tool to reach the targets like the higher cutting volume, a higher lifetime with a very smooth run. So we have the RF100 speed in two versions. The regular long version with a straight cutting edge for slotting, for roughing and finishing all in one tool. And we have the extra long version, which is in the cutting length between 3 and 4 times D. And additionally, we have the chip breakers in the cutting edge to reduce the length of the chips for the automated processes. With the regular tools you have, with the long cutting edge, you create long chips. And the long chips give an enormous volume in the machine. On the workpiece, it's difficult to evacuate these chips. So we designed the chip breakers to reduce the length of the chips. For example, on a 16mm tool, we have maximum 10mm chip lengths, and these are much easier to blow out of the pocket and get it out from the machine, and therefore we can guarantee a safe process. What we have to mention is, with the chip breakers, we have a big advantage on the roughing conditions to get the short chips, and we have to say in the finishing operation you will always see the little visible lines on the surface. So for the RF100 speed we designed a complete new face geometry. Because of the high helix of the tool with 48 degree, we weakened the wedge angle on the face geometry, and therefore we designed a very wide land angle to have a stable cutting edge. Additionally, we have a very big dash angle to create a big chip space when we do the plunging operations. And all this is designed in three-dimensional CAD system, and we have a complete new grinding instruction in our system. On this face geometry, we create the maximum stability when we do the helical interpolation to get the chips out of the pocket, and also in ramping angles we create a very safe process and we get the chips out of the workpiece. So the weakest point on end mills is always the corner where the wear comes first. So what we do is we make a big corner chamfer and additionally a big lip correction to protect this corner. We call this double protection. With this we achieve a high stability even in roughing, ramping and plunging operations, and therefore we can guarantee the maximum stability and the long lifetime. We have a very good experience with the many testings we did with our RF100 speed in difficult to cut materials where we achieved the outstanding performance. The lifetime is the most important issue together with the high cutting volume, and when we tested and benchmarked with our competitors, we achieved up to the double and higher lifetime. And even when we compare with our own RF100U, we have a much smoother run, the higher lifetime, and what is important, with the chip breakers and the short chips we create, we have very safe processes. The RF100 speed is our sharpest and fastest tool in the RF100 program range. With the 48 degree helix and the unequal flute spacing, we get a very smooth run. And additionally, in the long version, we have the chip breakers to get the short chips for a very safe process. For the applications in the aircraft, oil and gas industry and medical, where we meet all these difficult to cut materials, the RF100 speed is the first choice.